In this section we're looking at mean, variance, and standard deviation. Now we should know the mean is the average. So if you got a set of data or set of numbers, we would add up the sum of those numbers and then divide by the number of terms there are. And that gives us the average, but we're going to refer to that as the mean today. Now the variance and the standard deviation are two ways we determine how far the numbers are actually from the average. So let's think about a number line, and let's say I have a whole bunch of numbers spread out on there. Now the mean is going to be the middle of the average of those values. Now it may not be in the exact middle, that'd be the median, but it'll be close. So we have the mean there, and let's say we have maybe a set of data that's the same mean, but all of the numbers are a lot closer together. Now even though the mean may be in the same place, how far apart those numbers are do vary, and that's what we would use the standard deviation for. It gives us the average difference from the mean a value might be. So in our top number line it could be a lot, where on the bottom number line they could all be very close. And it'd be interesting, so like for example if we looked at test scores, if the average score of from a test was the same in for two different classes, but one class had a lot of really low scores and one had a lot of really high to kind of balance out, or you could have a class where all the mean or all the values are very close to the mean and they're really very well closely grouped. So that's what we're going to use the standard deviation and the variance to help us determine. So we have some steps to do this, and as you go through these you want to write these down, and we're just going to follow a process to solve it. The first thing we want to do is find the mean of the data set. So what we'll actually do is I'm going to make kind of a table out of it, where I'll start where I make a column with my data. So I'll list it out in a column, and maybe at the bottom I'll write the mean. And then after I figure out what my mean is, I'm going to put it in the next column. That's where the mean will go. Now the next step, step 2, says the difference between the value and the mean. So that's the difference, and that just means how far apart the data and the mean are. Now technically we need to pay attention to whether it's going to be positive or negative, but what the next step does, step 3, is where we square the difference. So we're going to square the difference from the previous column, and that's going to square it. We'll take all of those values, find the mean of that column, which is the variance, which is the 4th step, and then the last is to take that square root, and that'll give us the standard deviation. So it's going to follow that general process as we go through. Now if you're not sure what we have there, I would at least get the steps down, and as we go through the problems you can see how we do complete each step. So we're going to start with a set of data here: 11, 12, 35, 48, 14, and 30. I want to find the mean, variance, and standard deviation of that set. So I'm going to start with just listing out my values. I have 11, 12, 35, 48, 14, and 30. Okay, if I add all those values together, I get 150, and if I divide that by 6, I get a mean of 25. So that is the mean of those values. Okay, my next column over, I'm going to write the mean, list that down, 25, 25, 25, followed by the next column being the difference between the mean and each data value. So 11 and 25 are 14 apart, 12 and 25 are 13, then we go 10, 23, 11, and 5. So that is the difference. I'll write a note there. That is the difference between each. This was my data, and this was my mean. Okay, the next step we had on our list was we then square each of the differences. So I'm going to take each value in that column and square it. 14 squared is 196, 13 squared is 169, we get 100, 529, 121, and 25. Now, we're going to want to have the average of this because the variance is going to be the average of these values. So, I add them all up. I get 1,140 divided by 6, so this is the mean, and it comes out to be 190. So, this was that value we call the variance. Now, whenever we have the variance, the square root of that variance is equal to the standard deviation. So that's our last step. We know the variance is 190, so the standard deviation is the square root of 190, which comes out to be approximately 13.8 units. So what does that mean? We just found here that the average value of that data set was 25. But like I said earlier, that doesn't really describe the numbers enough. We want to find a little bit more about them. So what the standard deviation actually tells us is if you went from the average 25, that each data value is about 13.8 units away. It's on an average that far away. So we could then kind of classify the values, or maybe if we had another set of data with a similar mean, kind of see how that compares with the standard deviation. So you can think the average distance, or the average value away a data point is from the mean, is about 13.8 units. Okay, let's do another one. Same idea, just a different set of values. So now we have 14, 9, 5, 13, 8, and 11. So first thing we want to do is find the mean. And if we add all those up, it comes out to be 60 over 6, which gives us 10. So our second column is the mean, which will always be the same all the way down the column. And then we go the difference, now the difference from each data value to the mean, so we got 4, 1, 5, 3, 2, 1. Our next step is to square it. So now we're going to take the difference and square it. We get 16, 1, 25, 9, 4, and 1. We can add those all up, and that comes out to be 56. We want that mean, so 56 over 6 comes out to be about 9.33. It's 9 1/3, or 28 over 3 if you want to do it that way. So that means the standard deviation is equal to the square root of 56 over 6. By the way, this is our variance. Forgot to label there. Or the square root of about 9.33, which comes out to be about 3.1. And that is our standard deviation. So just based off that, we can actually go back to the last one we did. The last one we did, we found the standard deviation was 13.8. So 13.8 average away. Well, on this one, it's 3.1. So even in that, we can see it's a lot closer together. Now, you may have noticed these values that we got with the squares were a lot smaller this time, and it kind of led us to think it was going to be a lot closer. 16, 1, 25, 9, 4, 1. Those are a lot smaller than all of these values from the first one, where they're in the hundreds and a lot bigger values. Because really, the standard deviation is the average of all of those squares. Okay? Let's try a little something different. So now we're going to find the mean and standard deviation of 6, 10, 20, and 24. So I'm going to list my values as before. And if you need to draw out the table so you have all the values, you should be doing that. But I really want to focus on some changes here. So let's kind of do a little shorthand as we go through. 6, 10, 20, and 24 adds up to 60. We divide that by 4, so our mean is 15. Then the difference in that mean is 9, 5, 5, and 9. We square the difference, and we get 81, 25, 25, and 81. Now, our variance is the average of this last column. So our variance is 81, 25, 25, and 81. Added together gives us 212 over 4, which comes out to be 53. Now, once we have the variance, that means our standard deviation is equal to the square root of 53, which is approximately 7.3. And let's write the mean there as well, which was, oops, not 10, 15. Okay, so we did that. Now, let's follow some changes we're going to do. Now we want to increase each number by 4 and recalculate the mean and standard deviation. Okay, so we're going to, instead of 6, we have 10, then 14, 24, 28. If I add those all together, it comes out to be, well, let's just add it here. We get 6, carry the 1, looks like a 76. So that average divided by 4 comes out to be 19. Okay, we find the difference, 9, 5, 5, 9. We square it, 81, 25, 25, 81. Okay, do you notice anything? Maybe you see it. All right, the variance, we add up all of the squares, and we take the average, so that's, well, it happens to be 212 over 4, which comes out to be 53. And then that means the standard deviation is the square root of that, which is approximately 7.3. And again, like we stated earlier, our mean was 15. Well, okay, let's compare the two. So I added 4. What stayed the same? What changed? The mean, oops, I got ahead of myself. The mean was 19 in this example. That was second column. Now, the mean went from 15 to 9. So we added 4 to each value, and it added 4 to the mean. So if I took a set of values and I added the same amount to all of them, it would move up the average the same amount. Oh, okay, we can kind of see how that makes sense. But what's interesting is the standard deviation stayed the same. So even though we added and the mean changed, the standard deviation didn't. Now, I know I'm going to write some more down here, but let's think about how we could shift it first. Let's kind of jump down real quick and use this space before we erase it. If I had a set of numbers, and in those set of numbers I had a mean, and then I took those numbers and I shifted them up the same amount, kind of like in geometry when you had a translation. And I translated them to a new spot, and I had the same mean. Well, it makes sense everything would shift the same amount, so they'd all be the same amount apart. It's almost like picking it up and moving all of the values. Or you could even think about taking the number line and pulling that number line and shifting all the values, and the range would stay, that they take up would stay the same. Okay, so we added the same amount to each value. It added that same amount to the mean, but it didn't change how far apart the numbers were, which almost makes sense to why the standard deviation did not change. All right, now let's go look at our next example. Kind of clean up here. All right, now we're going to multiply each number by 3 and recalculate the standard deviation. So I have 18, 30, 60, and 72. So what do you think is going to happen? Well, let's find out. If I add 30, 60, 72, and 18, I get 180. 180 divided by 4 is 45. So that's my second column, the mean. I find the difference from the mean, that 27, or difference from the data values, 27, 15, 15, 27. I now square that, and I get 724, 225, 225, and 724. Now the variance is going to be all of those values from the squares, 1908, added together, and they're divided by 4, and I get 477. Okay, well 477, that's an interesting number. We're trying to find our pattern here. But actually, when we take our standard deviation of 477, it comes out to be about 21.8, which if we looked at the decimals out would actually be, I realize we're rounding, 3 times 7.3. Now, our mean was 45. That turned out to be 3 times the value we started with for the mean in the original. So, when we multiplied each value, it made the mean that much bigger by multiplying, and it also made the standard deviation that much bigger. Now, let's go to the next screen, and that'll maybe help us out. So, rules to change in a data set. If you have a set of numbers and each number is increased by the same amount, so increased, we add, then the mean increases that amount and the standard deviation stays the same. So kind of like what we talked about, we could shift, if we took a mean, we have our values and a mean, we could shift it to a new spot, but it doesn't change how far apart the values are, so the mean increases that amount, but the standard deviation stays the same. Because we didn't change how far apart the values were. They still stayed the same amount, so they're still average the same amount apart from the mean. Now, the last one we just looked at is when we multiplied. So now we're taking this set of data values, which we think are in here, and now we're taking them and we're multiplying those values and not only making them bigger, but we're actually putting them further apart. So as we multiply, we're taking the mean, and that gets multiplied, but the amount that the values are together also gets bigger apart. They've actually stretched out. Where they might have been very close before, since they multiplied, they get bigger, so they're actually further apart now, and the standard deviation is multiplied by the same value. So we can even, let's say we multiplied by k. Well, we'd multiply the mean by k, and we multiply the standard deviation by k, by that same amount each time. So let's go back and look. What the k value was, we could say on this one, is we multiplied each one by 3. So it made the mean 3 times bigger, and it made the standard deviation 3 times bigger. Now the variance, since it is the standard deviation squared, it doesn't quite work as cleanly. We're not going to actually worry about that. If you can find your mean and standard deviation, you're going to be good. So you can go now, try to start working on some practice ones. I would just make sure you refer back to the steps as you go through, and good luck.